Welcome to Digital Signal Processing. In this video, I am going to talk about periodic and aperiodic signals with examples. Myself, Dr. T. Veeramanindasamy from Veera Electrons. First of all, we should know the classification of signals. In my previous lecture, I talked about continuous time signals, discrete time signals, and digital signals. Both continuous time signals and discrete time signals can be further classified into four major categories. They are periodic and periodic signals, even and odd signals, energy and power signals, and deterministic and non-deterministic signals. Here we will see about periodic and aperiodic signals. For periodic signals, a continuous time signal x of t is said to be periodic if it satisfies the following condition: x of t is equal to x of t plus t naught for all value of time. So time value varies between minus infinity to plus infinity, where t naught is the fundamental period of the signal x of t. Let me take the continuous time signal x of t. Look at the time values. For 0 to 4, we can have the signal pattern like this. After 4, we can have the same pattern up to 8. Then that pattern will be repeated again and again. Okay, so if you look at the left side of that origin, for 0 to minus 4 and minus 4 to minus 8, you can have the same pattern. So that the periodic signal has definite pattern. That pattern repeat over and over throughout the signal. In the signal x of t, the same pattern repeat over and over throughout the time variable. So that signal is periodic signal. Then how can we calculate the fundamental period t naught? So we can have the formula t naught is equal to 2 pi by omega. T naught is equal to 2 pi by omega, where omega is angular frequency in radians per second. We know omega is equal to 2 pi f. F is frequency in hertz. Once t naught has calculated, that t naught should be rational number. Rational number means it is the ratio of integer. So if you have ratio of integer as the t naught, definitely that is the value t naught. That period repeats over and over throughout the limit of x of t. That signal x of t is periodic signal. For example, sinusoidal signals. So sinusoidal signals are always periodic signals. So the period will be repeated over and over. Then we are going to know about the periodic condition for discrete time signal. The condition for periodicity can be written as x of n is equal to x of n plus n naught for all value of n, where n naught is the fundamental period measured in a number of samples. Consider the discrete time signal x of n. X of n having many samples. For n naught, we can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So n naught having 13 samples. How can we calculate the n naught value? So the fundamental period n naught is defined as n naught is equal to 2 pi k divided by ohm. Ohm is angular frequency in radians per second in digital domain. So here k is smallest positive integer. That means number of envelopes in fundamental period n naught. So consider the signal. This is the starting point of the n naught, then this is the ending point of the n naught. So during this n naught, we can have the envelope. It starts from here, 1 and 2, 3, then 4. So throughout this n naught, we can have 4 envelopes, so that k value is 4. So k is smallest positive integer. So it representing number of envelopes in the fundamental period n naught. The n naught should be rational number for periodic signal. So the n naught is ratio of integer, means we have the valid fundamental period. So that period repeats over and over in x of n, means that x of n will be a periodic signal. So examples sinusoidal signals. Then aperiodic signal or non-periodic signals. A signal that do not satisfy the above said periodic condition is called a periodic signal. And a periodic function never repeats again and again. If you look at the signal x of t, it is the unit rectangular pulse. The signal value lies between minus 1 to plus 1. If you consider this is the fundamental period, that fundamental period is not repeated here. so that the x of t is a periodic signal. If you consider the real exponential function, so e power minus at, it is a decaying exponential function. Here any part of x of t is not repeated again throughout the time variable, so that the real exponential signals are non-periodic signals. Sometimes the signal may not have just one particular frequency, so consider this third signal. So each envelope having different time period, so that it should not be periodic signal. Then we'll discuss about the problems regarding periodic and aperiodic signal. So example 1, find whether the given signal x of t is periodic or not. We need to find the fundamental period of the signal. So the time value from 0 to 4, this is t naught. Then same signal pattern will be repeat again from 4 to 8 and so on. Okay, so this is the fundamental period. So fundamental period t naught is equal to 4. If you consider time in seconds, so the t naught is 4 seconds. T naught is rational number or not? 4 divided by 1, so this ratio of integers, the period t naught is a rational number, so therefore the given signal x of t is a periodic signal. Then example 2, find whether the given x of t is periodic or not. So the given x of t is cos 3 pi t plus pi by 4. The solution for this problem is the x of t having the cosine function. We need to write the general form for the cosine function. So that is x of t is equal to a cos omega t plus pi. Omega is the angular frequency, pi is the phase angle. So by comparing the general form with the given x of t, we are getting omega value. So this is also omega is equal to 3 pi. We are going to calculate the fundamental period t naught. So t naught is equal to 2 pi by omega. Substitute the omega value here. 2 pi divided by 3 pi. Then pi will get cancelled. Finally we will get 2 by 3. So it is the ratio of integer. So definitely it is the rational number. So therefore the given signal x of t is the periodic signal, and the period of the signal is 2 by 3. Then example 3, find whether the given signal x of t is periodic or not. X of t is sin t. The solution for the problem is the signal x of t having a sine function, so that we need to write the general form of sine function. X of t is equal to a sin omega t plus pi. By comparing the general form with the given signal x of t, we get omega value. So it is omega t. Okay, so sin omega t. So here phase angle is 0. Here the omega is 1. Now we are going to calculate the fundamental period t naught. So t naught is equal to 2 pi by omega. Here omega is 1. 2 pi divided by 1. So what about the pi value? 2 into 3.1415 and etc. The pi value having infinite fraction divided by 1. So it is definitely not a rational number. So therefore x of t, the given x of t is not a periodic signal. Then example 4, find whether the given signal x of t is periodic or not. So the given x of t is cos pi by 3 into t plus sin pi by 4 into t. There are two sinusoidal components in x of t. One is cos, another one is sin. So if we have more than one components in x of t, you can consider the first part as x1 of t, then second part as x2 of t. So first part is x1 of t is equal to cos pi by 3 into t. The second part is sin pi by 4 into t. By comparing this x1 of t and x2 of t with their general form, so we will get the omega value. So the omega value from the first part of the x of t is omega 1. So omega 1 is pi by 3. Then omega 2 is pi by 4. Okay, so omega 1 is pi by 3, then omega 2 is pi by 4. First we are going to calculate t1. T1 is equal to 2 pi divided by omega 1. So omega 1 is pi by 3. So pi will get cancelled. Finally we are getting 6. Then for t2, 2 pi by omega 2, here omega 2 is pi by 4, so pi and pi will get cancelled, and finally we will get 8. So t1 is 6 and t2 is 8. Then the fundamental period of x of t can be calculated as t naught is equal to t1 by t2. T1 is 6 and t2 is 8. So this is equal to 3 by 4. 3 by 4 is the ratio of integer, so that it is rational number. So therefore the given signal x of t is a periodic signal. Then we can calculate the fundamental period of the signal x of t. T naught is equal to t1 by t2. So that is equal to 3 by 4. Do cross multiplication and you will get t1 into 4 equal to t2 into 3. T1 into 4 equal to T2 into 3. Then substitute the T1 value as already we have calculated, that is 6 into 4. T2 value is 8 into 3. You will get 24. So that the fundamental period of the given signal x of t is 24. Then example 5, find whether the given x of t is periodic or not. X of t is equal to cos root 3 pi t. If we are going to compare the general form of cosine function with the given x of t, so finally we are getting omega value, so that omega t, so omega is equal to root 3 pi. Then the fundamental period of x of t is t naught is equal to 2 pi divided by root 3 pi. You will get 2 divided by root 3. So root 3 value 1.73205 and so on. So that it is not a ratio of integer. T naught is here irrational number. Therefore the given x of t is a periodic signal. Then the example 6. Find whether the given signal x of t is periodic or not. So the given x of t is sine squared 4t. We can rewrite the given signal x of t as, so from the formula of half angle sine functions, so sine squared theta is equal to 1 minus cos 2 theta by 2. So substitute that formula here, instead of sine squared 4 pi t, x of t is equal to 1 minus cos 2, instead of theta you can use 4 pi t, so 4 pi t divided by 2. Rewrite this equation as, so 2 is the common factor in the denominator, so you can write 1 by 2 minus cos 8 pi t divided by 2. So this is now our x of t. You can have the cosine function here. We can compare the general form of cosine function with this cos 8 pi t. So omega is equal to 8 pi. Now we can calculate the fundamental period. So t naught is equal to 2 pi by 8 pi. So pi get cancelled. Finally we will get 1 by 4. So 1 by 4 is the ratio of integer. Therefore the t naught is a rational number and the given signal x of t is a periodic signal. The period of that signal is 1 by 4. Thank you for watching.